eet105. This is a tutorial on example of powers of 10. For those of you that need a refresher on powers of 10 and the Greek prefixes and SI symbols, this is for you. So what I have is I have a file in Excel, and I have 3 steps in here. The first step is the blue step. It's just the number of decimal places. As you can see, it goes from 0 to 5. I didn't think going past 5 was necessary. So it names each place. This is the ones place, the tenths place, hundreds, thousands, 10,000s, 100,000s. So that's what that looks like, and it changes all of these numbers accordingly to the number of decimal places that you have set. The second part is the power. So it's the exponent or power of a base 10. So when I set this to 6, it's going to be 10 to the 6th, which with a caret, this is what it looks like. And then with a proper exponent superscript, this is what it looks like, standard superscript form. In straight up number format with 1,000 comma separator, this is what it looks like. And then scientific notation, once it gets into the bigger numbers, past the 11th power. This is the way Excel donates a power. It's that capital E, and then the symbol after it is either going to be plus or minus. Then the number after that is going to be the power. So this is 1 times 10 to the 12th power. That's what that is representing. The next line is the name of the large or small number. Right now we're in the trillions, which is 10 to the 12th. And then the final step that you can change in this file is you can type in the mantissa, which is also called the coefficient, which is a number between 1 to 1,000 multiplied by the power of 10. And then everything below that depicts what that would look like if you took this mantissa and multiplied it by this power of 10. So the number format with 1,000 separator looks like this. If we bring it down to something a little smaller, let's say 313.45678 times 10 to the 6th, or a million. So that's what this would look like. And then the next line is showing scientific notation, which means with a caret symbol, again, that symbolizes a power. So it's 10 to the 6th power. That's 313.46 times 10 to the 6th power is what that means. The next line is engineering format. So engineering format is any power of 10 that's a multiple of 3. Like 3, 6, 9, 12, 15, 18, or all the negative ones, -3, -6, -9, and so on. So it's only going to show that number as some type of multiple of 3. If you notice, so I'm going to set this to 10. In the scientific notation, it's 313.46 times 10 to the 10th power. But what this form does is it moves the decimal 2 places to the left and increases the power. So it reduces the value of the mantissa and then increases the power of 10 accordingly, moving 1 decimal point 1 point to the left is going to make this number 10 times smaller. So you consequently, to get an equivalent number, you have to make this 10 times bigger. So it moved it 2 places to the left. So it went from a 10 and increased it to a 12. And then the second format is still engineering power of 10 form. It just is showing you instead of the E, it's 10 to the 12th power, showing 10 with a caret. The last 2 forms, take that power of 10, and they convert it over in this table here to whatever power of 10 corresponds. This at this point it's 10 to the 12th power, which is tera, which is symbolized by a capital T, which is also equal to a trillion. So this would be 3.13 tera, whatever your unit is. I'm not going over units here, but if it was a terabyte, the byte would be your unit. And it can also be expressed with a capital T. These two are equivalent. So these 1, 2, 3, 4, 5, 6 numbers, these are all the same. They're just shown in different formats. So, like I said, you can play with this. You can go into the really small numbers. And again, in scientific notation, this would be 313.46 times 10 to the negative eighth, which is equivalent to 3.13 e to the sixth, negative 6. So what we did was we moved it 2 places to the left and then increased the power by 2. Since we made this number smaller, the mantissa, then we need to make this number bigger. So we added 2 to it. So minus 8 plus 2 equals minus 6. Notice when it's a multiple of 3, all 3 of them look exactly the same. But then if I go to, let's say, 13, here we go. You move the decimal point 1 place to the left to make this 31.35 times 10 to the negative 12 for engineering format. Engineering format is what we're mostly going to be using in this class. And the reason for it is that you can use these Greek letters and also the SI prefixes. This would still be pronounced to be 31.35 pico. It's just with a small p instead of it's being spelled out here.